Good evening. In this tutorial, I'll show you how to properly configure and prepare your ESP32 touchscreen board for programming. Let's start by installing Git. We're using a fresh installation of Ubuntu Linux for this setup. We recommend opening a Gemini tab and using the prompts shown in the video, so you can simply copy and paste the commands directly into your terminal. By default, a fresh Ubuntu install doesn't run app images. To fix this, we'll need to install a few compatibility packages. Also, right-click the app icon, go to Properties, and under the Permissions tab, check the box to allow executing file as program. Now, simply copy and paste the command shown on screen into your terminal. To avoid any compatibility issues, we recommend downloading the app image directly from the official Arduino website. Also, right-click the app icon, go to Properties, and under the Permissions tab, check the box to allow executing file as program. All set. Now, go ahead and open the Arduino IDE to begin the setup. While the IDE is opening up, let's go ahead and download the project repository. While you could simply download the zip file, we're going to use Git to clone the repository. Copy the repo address and build the Git command. Feel free to use Gemini if you need help with the syntax. Now, paste the Git command into your terminal and wait for the repository to finish downloading. Now, let's install the ESP32 board in the Arduino IDE. Go to Preferences and paste the manufacturer's URL into the designated field. While you're at it, check the verbose output options for both compilation and upload. This is essential for getting detailed feedback if you run into any issues later on. Now, we'll install the board and core libraries. Go to Tools, then Board, and select Boards Manager. Search for ESP32 and make sure to choose the official package from Espressif. Version 3.3.1 has a much smaller footprint than the latest ones. For this project, I recommend sticking with this specific version. If you have a fast connection, the installation should be quick and painless. However, on slower connections, you'll need to increase the compiler's timeout. Take a look at the error that pops up. To increase the timeout, you'll need to find the Arduino YAML file and update the parameter there. Use the command shown on screen to locate the exact file path. It should be one of the first results, so there's no need to wait for the full scan. Press Ctrl+C, go to the first result, and edit the file using the nano command. Now, insert these lines as suggested in the Arduino forum. To find the correct discussion and dive into the details, search for these keywords on Google as shown on screen. Just paste these two lines into the file. Press Ctrl+O, then enter to save, and Ctrl+X to exit. Now that the file is modified, close the IDE, reopen it, and try installing the board again. It should proceed normally this time. If you have a slower connection, this might take a while, but as we can see, everything has been successfully installed. Now, let's select the correct board. Based on the hardware specs from GitHub, choose the ESP32 dev module from the boards list. Once your hardware is plugged into the PC's USB port, select the serial port that represents your device. When selecting the serial port, it's common for Linux to deny USB access due to permission issues. You can ask Gemini how to fix this permanently, but in this video, we'll set up a quick, temporary fix using the chmod command. After running the command, we check again and see that the device can now connect via serial. Since this module is pre-flashed, it starts sending data right away, according to the program logic. And don't forget, To ensure the data reads correctly, set the boot rate to 115,200 in your serial monitor. Before organizing the directories, let's generate our API key. Ideally, you should run your own LNbits or Alby instance, but for testing purposes, feel free to use my instance shown on the screen. Now that everything is set up, open the project code and look for this specific line in the .ino file. Whether you're using your own instance or the account you created on mine, go to this section to retrieve your access key. Select the specific key for creating invoices and paste it into the designated spot in your Arduino code. In this code, the program calls an API on my VPS. If you're using your own instance or account, you can simply call the invoice creation API directly. The send endpoint is available in the Python code on GitHub. As soon as you run the app image for the first time, it automatically creates an Arduino folder in your home directory. That's where you need to copy the libraries folder from GitHub, as well as the complete project folder. To avoid the out-of-memory error you'll see next, you must change the partition scheme of your ESP32. Go to the menu and select the Huge App 3 MB No OTA mode. With everything set up, just click Compile and Upload. Be patient, as the process usually takes a bit longer the first time around. Now that the firmware is flashed, reselect the serial port to restore the connection. We're all set. Now, go ahead and create an invoice directly on the physical device. As soon as the device generates the invoice QR code, just make the payment through your phone and wait for the confirmation. This is the proof that the Lightning Network integration is working perfectly. Congratulations! You now have the tools to reject fiat currency to an even greater degree and embrace true financial sovereignty. Please share, subscribe, and like the video. And if this tutorial was helpful, the project also accepts Bitcoin donations. You can find the address in the description.